Bismillahirrahmanirrahim. Mrs. Sobia Suhail is here. Assalamu alaikum to all my dear students. How are you? Hopefully doing well. So today I will explain the parametric equations. Okay, I have taken this topic from unit number 2 of exercise 2.4 and the class is second year maths. So before doing this topic, you must know what is the parametric equations are. Okay, parametric equations are those equations in which two variables, suppose y and x, these are the two variables, they are connected to the third variable, that is, we can say mostly which is being used like a t variable. Y is a function of t, x is a function of t. Okay, and they both are connected with each other with the function of t. You have to solve and eliminate this t, eliminate this t, so that x and y are connected to each other. They are called parametric. Here t is behaving like a parameter. Okay, so in this one we will solve the parametric equations by the chain rule. In this book, the question which is giving relevant to this topic, like question number 3, first part, x is equals to theta plus 1 over theta and y is equals to theta plus 1. They said that find dy by dx. Find out. X is expressed in the term of theta, y is expressed in term of the theta. It means the theta is a parameter over here. This is the important point for the objective point of view. Okay, so x will be we will find out the different derivative of x with respect to the variable involved, that is theta. Okay, so dx over d theta we can find out. So d by d theta of theta plus, can I write this as theta inverse? Okay, now d theta by d theta plus d by d theta of theta inverse. Now this will become 1 and this become power in start, power minus 1 and the derivative of function without power. So this become 1 minus theta minus 2. It becomes equals to 1 minus 1 over theta square. Still it can be equals to theta square ones are theta square minus 1. It's okay, this is the dx by d theta. We express this in the one fraction. Okay, now take y. Y is equals to theta plus 1. dy by d theta. Now d by d theta of theta plus 1. Its derivative will be 1 and it will be 0. So the answer will be 1. Now we have to find out the dy by dx. So using the chain rule, we need to find out dy by dx involving theta. It means dy by d theta and d theta by dx will be there. Okay, so parameter will be in the cross over here. Put the value of dy by d theta, that is 1. And this value is dx by d theta. If you check once again, it is dx by d theta. So this value will be, you have to take the reciprocal of its value. Okay. So its reciprocal will become theta square over theta square minus 1. Multiply by 1, it will remain same. Good. dy by dx is done. That's why I said that express this in one fraction so that the inverse can be taken easily. Okay, its reciprocal can be taken easily. Next. Okay, in the same exercise I write the next part also and I write question number 4 also. In this one, x, it will be differentiated with respect to t and y with respect to t. So you will write down dy by dx equals to dy by dt into dt by dx, because x and y function are same in this question, and next you have to get the proof also. So that's why I will solve this and hopefully it will clear your this question as well. Okay, only a and b are different, remaining full question is as it is, and a and b will stay as it is with the derivative because they are the constant numbers. Okay, take this one first. Take x equal to 1 minus t square and 1 plus t square. differentiate with respect to t. Here and here. We always differentiate with respect to the variable involved. Okay. Now quotient rule will be there. This rule is saying that square of denominator, then okay, denominator as it is, derivative of numerator minus yeah, yes, numerator as it is, derivative of denominator. Is that okay? Now this will stay as it is. Okay. And in this one, 0, 0, derivative of constant number is 0 minus 2t minus 1 minus t square 0 plus 2t. I make a big mistake over here because normally we are doing with the x. So by mistake I write with x. But, even it is with t. So don't repeat this mistake. We are doing the derivative with respect to t. That's why dt over dt is equal to 1 here. Okay. Denominator staying same. Check your own working after completing the steps that where you are doing. Okay. Now 2t and 2t. Can we take it as common? When we take as common, negative sign multiply with these two terms, minus 1 and t square. Okay, now minus 1 minus minus plus t square divided by same. Okay, now 2t will be staying outside, minus 1 minus 2 and they are cancelling. 1 plus t square then whole square. Okay, this will become minus 4t over 1 plus t square and then square of that. This is the answer of dx over dt. Is that okay? Then next, now we have to take y. Now take y is equals 2t over 1 plus t square. You can come here. Yeah. So dy by just dy by dt, d by dt on same. Okay. In the next step, we apply that one 1 plus t square whole square, then denominator as it is, derivative of numerator, that is 2 minus numerator as it is, derivative of denominator. It's okay. 1 plus t square 2, okay, minus 2t and 0 plus 2 in start, t 2 minus 1 and derivative of t 1, so 2t 1 plus t square whole square. It's okay. 2 and 2 common only, t is not here, only 2 common. So when I take 2 common, it will become 1 plus t square minus t and t square. 1 2 I take common, other 2 is still there. Yeah, over 1 plus t square and whole square. This become 2 1 plus t square and minus 2t square minus 1 time t square, 1 plus t square and whole square, dy by dt. Is that okay? Now this is our first equation and this is our second equation. From 1 and 2 by chain rule also, dy by dx equal to dy by dt over dx. So putting the value here, dy by dt, this is the value of this, 2 times 1 minus t square over 1 plus t square whole square, multiply reciprocal of this function. Okay, 1 plus t square whole square divided by minus 4t. When we have written like this, this is fully cancelled. Out of these, 2 ones are, 2 twos are. So this is 1 minus t square over this left. Okay, so finally, yeah, dy by dx we are obtaining as like 1 minus t square and
over minus 2
minus 2t. Okay. Now they have asked to prove that one. Okay. Y times dy by dx plus x equals 0. Put the value. The value of y was 2t over 1 plus t square. dy by dx is 1 minus t square over minus 2t plus x value is 1 minus t square over 1 plus
plus t square.
t square equal to 0. So this is cancelled to this. This whole term is not cancelling, but negative sign will be outside. 1 minus t square over 1 plus t square plus 1 minus t square over 1 plus t square. Whole fraction we can write. So cancel to this, 0 equals to this. So hence proved. It's okay. In the same exercise, uh, let me continue the question number. Next question is that question number 5. Differentiate first function x square minus 1 over x square with respect to the second function x4. What we will do in this one question, x is involved in both. Okay, so this will be the parameter. Okay, one we can let this is equals to y, and one we can let this is equal to which variable you want to use.
Z.
Z. Okay, it was also coming in my mind to use Z because we have used theta also, t also. Now try z.
Exactly.
Okay, with respect to z. Now differentiate this with respect to x, this also with respect to x. It will become dy by dx and d by dx of the function x square minus x minus 2. Yeah, it become 2x and it become power in start power minus 1 and derivative of x, that is 1.
Without, yeah.
Okay, so 2x minus minus plus 2,
Plus 2
x become minus 3. It can be written as 2x plus 2 over x cube because we have to write in the one fraction form. Okay, so what we can do in this one, that take the LCM or make the denominator same, as this is there is 1 as a denominator, so this full fraction will multiply to the numerator. X cube times 2x, 2x4 plus 2. So this is one fraction dy by dx. In the same, there is huge space we have, we can use it. Dz by dx, d by dx of x power 4. Okay, power in start power minus 1 and derivative of the function is 1. So this is the answer of dz by dx. Now dy with respect to dz. Okay, parameter is x now. So dy by dx into dx by dz. This will be as it is, 2x4 plus 2 over x cube. Multiply. There will be reciprocal of it. Yeah?
1 over.
Yeah, 1 over 4x cube. 2 can be common and cancel with 4. So here left x4 plus 1. And here will left 2. X cube and x cube.
X6.
6. It's done. I think the next part you can do easily in the same way.
Yeah.
Okay, so thank you so much. If your topic is cleared, so next video I will make with respect to the new topic. Inshallah. Until then, thank you so much.